Hello and welcome to the second session on natural language processing. In the first session, we have covered the basic introduction to natural language processing. Also, we have tried to apply the concept of NLP to a real problem scenario. The case study what we have taken here is the reviews of the restaurants, and we have to train the machines to understand each review is a positive or a negative. Okay, so this is the case study here, wherein we have two attributes. The first column is a review, the second column is liked here. Okay, so here the liked is a dependent variable vector where we have all the binary inputs, zeros or 1, and in the first column we have all the reviews of the restaurants. So in the first session we have tried to import all the libraries and the data set. Okay, and since the dataset was a TSV file, tab separated value, we had used the delimiter as a /t, and of course we had used the quoting as 3, since to get rid of all kind of quotations like double quotes, single quotes or any other kind of quotations. Okay, and after that we had tried to clean the text. This is the pre-processing stage happens in natural language processing. So to remove all kind of stop words, punctuations, all these things, we require to clean the text before we build the model. So to do that, we have imported necessary libraries like RE and NLTK, and we had imported the class called as stop words and port stemmer. Okay, and since the data set was having 1000 instances of data, we had went through the for loop mechanism here, and we had applied the cleaning of all the stop words for each and every single reviews in a restaurants. Okay, and we had used that, and we have removed all the characters other than the alphabets here, and we had replaced those non-relevant characters with the space, and of course we had updated the same into the data set, right? And also we had tried to replace the uppercase to the lowercase, and of course we had used the split method so that the words are not stick to each other. And then we had applied stemming process. Stemming process is applied for each and every single word by word from the entire sentence, and we have put them all into the bag of words. Okay, that is this corpus list. So till here we have completed in my first session. Now let us start the remaining session to create the bag of words model, and let us also train using a few of the classification algorithm, and finally we are going to estimate the performance of the model using confusion matrix and accuracy. Let us do that now. So now let us implement the most essential step, which is the heart of the sentiment analysis, that is creating the bag of words of model, right? As all our reviews are properly cleaned in the earlier process, so we are gonna get them into the bag of words model to create a sparse matrix which will contain in the rows the different reviews from the corpus, and in the columns all the different words taken from all the different reviews, and each cell either get 0 or 1, right? So it will get 0 if the word of the column is not in the review of the row, and it will get 1 if the word of the column is indeed the part of the words in the review of the rows. Okay, so the process of creating all these columns corresponding to each of these words taken from all the reviews is called as a tokenization. So now let us create the bag of words model. So to do that, we have to import a class called as count vectorizers. Okay, count vectorizer from the scikit-learn library, and we have to import this module called as feature underscore extraction, and also with the submodule text. So from this module we are going to import a class called as count vectorizer, and later on we are going to create the instance of this class by giving a parameter of maximum features. So here maximum features means the maximum size of sparse matrix. Okay, that is what is the maximum number of columns required here. What happens here is, finally when you try to clean all the text here, we are going to put all those word by word into this corpus list, and that is nothing but the matrix of features for us. Now to convert that into the sparse matrix, okay, we have to select what is the maximum number of features required to train your model, and to do that we have written the maximum features as 1500. So I will also tell you why we had selected 1500 and what made us to select 1500. So to do that, first of all, what I will do means I'll just remove this line of code and I will use it later on after I confirm myself that the maximum features which I'm going to have is 1500. Okay, so once I create the instance of this class, I try to fit and transform the model to the corpus, wherein this corpus is going to have all kind of pre-processed words of those text for all the reviews. This fit transform method, which will indeed fit the corpus to X, means that it will exactly take all the words from all the reviews of the corpus and transform all these words in different columns. Okay, so this is where you are going to convert the whatever the words which is stored in the corpus list into the sparse matrix, and finally we are going to convert it into 2 array, right? So this means that as the matrix of features must be in 2D array, we have to invoke this method called as 2 array. So we convert everything into the array list, right? And finally, so this becomes your matrix of features X, and the last column, okay, that is the light one, that will be your dependent variable vector. So we are going to take the index position from those data set, accepting all the rows and only the last column, and that will be the final dependent variable vector. Okay, so now we are ready with this. So let us try to understand what is the maximum number of features we need to select for this bag of word model, right? Which will be our future sparse matrix, right? So without entering that maximum features, let me show you why did I select 1500. So first of all, I would like to execute all the necessary libraries here along with the data set. So let me do that first. Yes, after that it's my time to clean the text and put that pre-processed text into the corpus list, and after we do that, it's time to create the bag of words model, right? And yes, we are ready with the bag of words model here. So we have got all the words from the given text. All these are pre-processed words here. So let us see the first text here. So the first text was wow, loved this place. Okay, and this entire text has been replaced with wow, love, place. So you can see it very clearly that these punctuations and all other characters have been ignored, and it has been replaced with the space, and the loved, okay, the past tense has been converted into the present tense, that is love, and this was the stop word, so we had removed that successfully, and only those words have been considered which will contribute to the prediction of the model. Okay, and although you can see that there are few other words which are not actually required, and of course it is not going to contribute nor going to give any kind of hint to for the prediction of the model. Okay, for example, let me take texture. Okay, and of course I can check for this for or something else. Okay, there are certain number of words which will not able to contribute well for the prediction of the model, so it's time to remove such kind of words also. So to do that, we have to select what is the maximum number of features which we are going to consider. Okay, so that we take only the frequent number of items, okay, frequent words which are going to get repeated, only those words we are going to select. Rest of the words we will still ignore from this bag of words model. And to do that, we require to take the length of the matrix of features X, and let us see what is the answer we get, and based on that we can decide what is the maximum number of features we would like to select here. Okay, so let me execute these lines of code and let us predict the answer. Okay, we got 1566 total words in the bag of word model. Okay, and among which you might have seen there will be several irrelevant words which will not contribute to the prediction of the model. And to do that, let us remove and round it off to 1500. This is why we are done to 1500. You can even vary this value based on the accuracy of the model. Okay, for time being I'm going to consider it as a 1500. That means out of 1566 words I am still going to reduce 66 words which will not contribute to the model. Okay, so if I do that, what happens, of course it is going to remove all kind of other words which are not frequently getting populated. Okay, so to do that we have to write this as a parameter for the count vectorizer. Okay, now let me execute it once again, and now we are ready with the creation of the bag of words model. Now let us try to split the data set into training set and test set. This is as usual procedures we have to do that. So to do that we have to import this class from this module model underscore selection, and finally you have to train and test the model. To do that we have to take the testing set of 20%. Okay, that is 200 instances of data, and rest 80% will be considered for the training the model. Okay, so the random state is 0. Fine, so we'll split the data set into training and testing. After we do that job, we have to train these data with the one of the classification algorithm, right? So right now I'm going to consider the naive Bayes model to train this particular case study on this natural language processing. So to do that I import Gaussian NB and create an instance of that and fit that model to the trained data set. Let us do that, and after we get the accuracy of the model, we'll decide which will be the best model which will suit better to this kind of case studies. Okay, so we can see that the model is ready, and of course we are going to predict the test set results. And to do that we have to invoke a method called as predict from the classifier and predict all the test set results. Okay, and to present the output here, since it is not a two-dimensional, more than two-dimensional, we can't present it in a graph. So we can do that in the format of list. So we can make use of this concatenate operations, and the first parameter is a prediction value which is going to populate vertically, and next parameter is the tested value which is also going to populate vertically, and all this step, each and every step is going to populate horizontally. Okay, and let us try to predict all the results. So let us do that, and of course we can see we have got all the results here, and the starting few results are proper, and you can see there are many incorrect results also being populated here. Okay, let us not worry, we can fine tune our program and we can try to gain better accuracy for this. Okay, now it's time to make the confusion matrix for the model, and also we'll understand what is the accuracy of the model. To do that we have to import this confusion matrix and accuracy score from the module metrics, create an instance of the class and pass the test set and the predicted value of y, and execute those lines of code. So you can see that 55 plus 91 right predictions have been made, and 42 plus 12 wrong predictions made, and which led to the accuracy of the model to 73%. Okay, not a bad accuracy, but still you can still fine tune your program by you can just train it with the various other models. You can see as we have gone through with the earlier sessions, we had came to know that SVM provides a better accuracy to the model. It performs better comparatively to the other machine learning classification algorithm. Of course it depends upon the case studies, but still let us try to implement SVM model on this case study, and let us assume, or let us wait whether we are going to get a better results or not. Okay, so let us do that, and we are going to copy these lines of code and we'll paste it here. Okay, and of course I had used kernel SVM here, radial basis function, and let us execute it once again, and let us compare our results with the naive Bayes model. Okay, yes, the model is ready. Now it's time to predict the output and to, yes, we got 78%, 5% more results, we got more accuracy. Okay, like that you can check it for all types of models here. So as per the test what I made for which includes all the classification algorithms, so I found better results for the random forest and for the SVM model. Okay, but I found least accuracy for the KNN. It depends upon the case study what you take. Also, we can also think about, we can also fine tune these uh, numbers here. Okay, the bag of words model, the maximum number of features which you are going to consider for the sparse matrix can also be fine tuned, and you can still increase the accuracy of the model. Okay, if I make it to 1550, say 1550, okay, so we got 1566. So only 16 data I am going to remove, rest all I am going to consider. Of course, you will get a better results comparatively to the past results. So let us try to execute these lines, and let me now predict the test results. And you can see that we got the same 77.5 results. Okay, so you will always try to fine tune this, and of course you can also use some more methodologies and methods to pre-process your text data. Okay, so to pre-process it better, so you can try to fine tune this code, and of course you are going to get a better results than the results what we get here. Okay, the more number of instances in the data set, the more it will train the model, and of course for the test set it will give you better answers. Okay, so with this I would like to come to the conclusion of the natural language processing session. Okay, I wish you all the best and happy learning.